I am Sushma, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering College. In this session, we are going to discuss about the number system conversions. In this session, we will discuss why do we need various number-based conversions, decimal number system to another base conversions, binary number system to another base conversions, octal number system to another base conversion, and hexadecimal number system to another base conversions with examples we will discuss in this session. So before going to discuss about the conversion of one number system to another number system, just we will recall what is the basic number systems, and we will start the number system conversion. Okay, here in the basic number systems are represented by either decimal or binary, octal and hexadecimal. So decimal is nothing but any number that the radix indicates the number system. So here the base 10, that is nothing but radix 10 indicates this number. Suppose 125 base 10 is decimal number. If the radix is 1010 base 2, the radix is 2, then that is binary number system. If the radix is 8, then that number system is octal number system. If the radix is 16, then that number belongs to octal number, hexadecimal number system. Okay, so here in the decimal number system, the base is 10. For binary, the base is 2. And for octal, the base is 8. And hexadecimal, the base is 16. In decimal, the digits will be from 0 to 9. We will represent the digits in the decimal from 0 to 9. In the binary, either the digit will be 0 or 1. Only 2 digits we will represent, either 0 or 1. In octal decimal number, octal means it's 8. The radix is 8. So it is starting from 0 to 7. The digits are represented from 0 to 7. And the total 8 digits we will represent here from 0 to 7. In hexadecimal number system, the base is 16. Here the digits are starting from 0 to F. So here we will use 9 digits and 6 letters. So how we will represent that binary, decimal, octal and hexadecimal numbers. So here the binary number 0, 1 up to 0, 1 to 9, and after 9 we will write 10 to 11, 12, 13, 14, 15. So daily in our daily we will use decimal systems in our daily life. Binary is here either we will represent digit by 0 or 1. So here to represent 2 in the binary. Okay. So first we will divide 2 by 2. So 2 1s are 2. The remainder is 0. So 1 0. So we are representing 2 by 1 0. If it is 3, 2 1s are 2. The remainder is 1. So we have to represent that by 1 1. So 4 is 2 2s are 4. Remainder is 0. 2 1s are 2. Remainder is 0. From down to up, you have to write those numbers. We will discuss how to convert these numbers from one number system to another number system. So here 4 is represented by 1 0 0. So here the number system in the binary, each digit either it may be 0 or 1. Only we will represent each digit by either 0 or 1. In octal number system, it is starting from 0 to 7. Only each digit will be represented from 0 to 7. The 8 will be represented by 10. How? 8. So we are representing it by octal. So divide 8 by 8. 8 1s are 8. The remainder is 0. So from down to up. So it is 1 0. 9 means we are representing in octal. 8 1s are 8. The remainder is 1. So it will be represented by 1 1. So it is each digit represented by either 0 to 7, and after 7, 8 will be represented by 1 0, 9 will be represented by 1 1, 10 will be represented by 12, 11 by 13, 12 by 14, 13 by 15, 14 by 16, 15 by 17. Okay. In hexadecimal number, so we have to represent each digit by 0 to F. Okay. So after 9, the 10 will be represented by a letter A in the hexadecimal number. 11 will be represented by B in the hexadecimal. 12 by C, and 13 by D, and 14 by E, and 15 by F. Okay. These are the basic representation of number systems in the decimal, binary, octal and hexadecimal number systems. So why do we need various number system conversions? So the number based conversions are essential in digital systems. Mostly in all digital systems, the input is in decimal input, but it takes as binary number for the computation by decimal to binary conversion. So if we take computer, for example, if we take computer, the input we are giving to the computer by using keyboard either letters or digits. But the computer will not understand these letters and digits. So it will convert these letters and digits into binary format, and it will do computation. Again, it will display the decimal letters and digits by converting binary format into decimal format. Okay. So most of the all digital electronics, the computation will be done in the binary format only. Okay. So the application of binary digital system is in digital systems we will use for the computation we will use binary format. For digital hardware, the natural numbering system is binary. So any digital hardware, if we take the natural number system we will use is binary. But expressing in binary causes it is too lengthy to express the large numbers in the binary. So for that we will go for hexadecimal, which will use the 4 times fewer bits to represent the binary number. So it is hexadecimal number uses 4 times fewer bits compared with binary number. So mostly hexadecimal numbers will be used to represent in the microprocessor where programming or for memory location 0000A1 like that. Okay. So for to represent memory locations or for programming in the microprocessors, we will use the hexadecimal number system. So the hexadecimal number to make coding for microprocessor, but it converts that to binary for computation. The result will be in hexadecimal format by inverse conversion. So it will convert the hexadecimal into binary and it will do the computation. Again, it will convert the binary into hexadecimal conversion. Hexadecimal number system is often used by programmers to simplify the binary number systems. So where we will use the hexadecimal number system to for programming to simplify the binary number system. The use of, so in binary number system we will use in the all digital systems. For computation we will use binary number system. Hexadecimal system in microprocessors or microcontrollers. For programming we will our memory address location we will use hexadecimal system. The octal numbers has declined as most modern computers no longer base their word length on multiples of 3 bits. Suppose I want to represent a data D with 3 bits, so 2 down to 0, that is nothing but D2, D1, D0. My data will be in 3 digits. So to represent that one, so that 000, 001, 010 up to 111. So to represent the data, we will use octal number system. For example, in the Unix file system permissions, we have to represent the data in terms of 3 bits. So suppose 1 bit is for read, 1 bit is for write, and 1 bit is for execute. So to represent this bit set of 3 bit permissions, read, write, execute, we will go for octal representation. So most of the nowadays, most of the human beings daily in life, we will use decimal number system. So now conversion of number system. So number based conversion, it is, we have numbers systems are either binary or decimal, octal or hexadecimal. So from first we will study about the how to convert the binary to decimal, how to convert one binary number to decimal, binary number to octal number, binary to hexadecimal. Then if we have decimal number, how to convert decimal number to binary, and decimal to octal, and decimal to hexadecimal. So decimal to other number systems we will study in this. Now octal to other number systems. So octal to binary, octal to decimal, and octal to hexadecimal. In hexadecimal to other number system, here we will use hexadecimal to binary, and hexadecimal to decimal, and hexadecimal to octal. So we will see the procedure how to convert one number system to another number system with some examples. So here, if before going to know the procedures, first the conversion of number system has two parts. So any number, some numbers will be represented only by integer part. Some numbers will be represented by integer part plus fractional parts. So if we have both integer and fractional parts, so those will be represented by like this. If it is a binary number system, so 1011.11. So whatever the left side of this binary point, that will be integer part, this will be fractional part. Okay. So in hexadecimal also, each digit will be represented by 0 to f. So either from 0 to f. So this part is integer part. The right side of the hexadecimal point is fractional part. So how we have different procedure to convert the integer part and fractional part from one number system to another number system. Another one, if we take a number, for example, this is a number in the binary system, because each number is represented by either 0 or 1. So by seeing this radix number, we can say that it is a binary system, and each number will be represented by either digit will be represented by either 0 and 1. So in this bit, this right hand first bit will be represented by LSB, and this bit is called as MSB. That is most significant bit, and this is called as, this one is called least significant bit. So the right side, the rightmost bit is called as least significant bit, and leftmost bit is called as MSB bit. So conversion of decimal to other number system. So first we will discuss how to convert the decimal number to binary number system, and octal and hexadecimal system. So if we have any decimal number, how to convert the decimal number to binary number system, octal number system, and hexadecimal number system. So here, if the decimal number contains both integer part and fractional part, then convert both the parts of decimal number into other bases individually. So if we have, suppose decimal number is 95.67. Okay. So if we have this decimal number, so this 95 is integer part and 67 is fractional part. This is integer part. Okay. So we have to convert these integer part and fractional part individually by this procedure. Okay. So first what we have to do, what is the radix here? R is 10. Okay. So division of integer part of decimal number and successive quotients with base R, and note down the remainder till quotient is 0. For example, I want to convert this into base 2. So here the R is equal 2. We want to convert the decimal number into binary number. The binary number radix r is equal to 2. So we have to take r is equal to. So here, suppose I want to convert decimal number into binary number system. So here the binary number system is represented by r is equal, radix is equal 2. So do division of integer part of decimal number and successive quotient with base r and note down the remainders till the quotient is 0. So for example, I have 12. Okay, I want to convert this 12 is a here decimal number. I want to convert this into binary number system. So here first divide this decimal number with the radix r is equal to 2. So 2 6 12. The remainder is 0. Note down that one. Next, again take this quotient 6 and divide that by radix 2. 2 3 6. Again remainder is 0. Then 2 2 2 1 2. The remainder is 1. So again after that we can't do the division. So write down the numbers from down to up 1 1 0 0. Okay. This is equivalent of binary number 12. Decimal number 12 will be represented by 1 1 0 0. So we will discuss this procedure with the examples. Okay, just to understand that I explained that example. So here, do division of integer part of decimal number and if any number to convert that into decimal number to convert into binary. So we have to divide that number with the 2 and we have to take this successive quotient and again we have to divide that by base r. Okay. If it is octal means we have to divide it by 8. If it is a hexadecimal means we have to divide it by that 16. And we have to note down in each stage we have to write down the remainder of that values. Consider the remainders in reverse order to get the integer part of the equivalent number of base r. Okay. For example, if we have the number x to convert that into octal number, so we have to divide that x number with the 8 and we have to note down the value of the remainder in each stage and we have to take the quotient y. Again we have to divide it by that y and we have to take the quotient and remainder. Okay, like that up to we have to do this procedure to till the quotient should be the 0 or 1. Okay. So that means first and last remainders denote the least significant bit and most significant bit. So this is LSB and this is MSB. We will discuss the problem, then you will understand that one. So do multiplication of fractional part of decimal number and successive fractions with base r and note down the carry till the result is 0. For fractional part, suppose 0.2 is there. So to convert that into this decimal number into either any base system, from decimal to any base system. So we have to multiply each the decimal number with the radix number. Okay. Do multiplication of fractional part of decimal number and successive fractions with base r and note down the carry. Note down the carry till the result is 0. Or the desired number of equivalent result is obtained. Consider the normal sequence of carry in order to get the fractional part of the equivalent number of base r. So we will see some example how to convert the decimal to binary number system and decimal to octal and decimal to hexadecimal. So here, if it is a conversion of decimal to binary number system, first what we have to do, we have to take that number. We have two parts here. If it has a integer part as well as fractional part, first divide the integer part and successive quotients with base 2. Okay. For fractional part, we have to multiply that fractional part and successive fractions with the base 2. For example, so here I have only integer part 125. So this is the decimal number I want to convert that into binary number. So what I have to do? So binary, the radix is here r is equal 2. So take that number 125 and divide that 125 by 2. So 262 is 124. The remainder is 1. And take this quotient 62 and again divided by the radix 2. 2 31 is 62. The remainder is 0. So 2 15 is 31. Remainder is 1. 2 7 is 15. Remainder is 1. 2 3 is 6. The remainder is 1. 2 1 is 2. The remainder is 1. 2 0 0. The remainder is 1. So to get till the quotient 0, we have to do this procedure. Okay. So we have to take the radix value, that is here we are converting the decimal number into binary number system. So divide that decimal number with the 2 and take that quotient and remainder. Again divide that quotient by 2 and take that quotient and remainder. So till we have to do this procedure up to we have to get the quotient 0. Okay. And next, so how to write this binary number? So from down to up. Okay. This is MSB bit. This is LSB bit. Okay. So write down. So first digit is 0. This is 1, 1, 1, 1, 1, 0, 1. So this is LSB bit. This is MSB bit because the rightmost 0 will not be considered here. So this is the conversion of integer part of decimal number to binary number system. Again, if we have a fractional part, suppose we have 0.625. This is one example. It contains only fractional part. How to convert this fractional part into binary number system? So here, in the integer part, we divided the number with the 2 and we consider in each stage what are the remainders. But in the fractional part, we have to multiply the number with the 2. We have to multiply the number with the 2. So here 0.625 into 2 is 1.250. Okay. In that, leave this integer part and consider only fractional part in this number, that is 0.250. Okay. 0.250 again will be multiplied by the 2, then it is 0.500. In this only consider this fractional part, that is 0.500 is multiplied by the 2, then we will get 1.000. So here we got the 0. If we multiply 2 also, we will get the 0. So if we this procedure will be repeated up to same number will be repeated in the fractional part. So here 0. In this, consider only this integer parts, that is from up to down. So this is MSB, this is LSB. So write down like this. So 0 point after this decimal binary point. So this is MSB 1, 0, 1 base 2. From up to down. So 1, 0, 1, 1, 0, 1 we have to write down. This is the procedure to convert the integer part and fractional part of the decimal number to binary number system. So what we did here, for integer part, we divided the number by 2 and we note down the remainders. This procedure, the procedure will be repeated up to the quotient should be 0. And write down the values from down to up. That is, this is the MSB to LSB. So write down this one. 0, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, 1. Okay. This is for integer part. For fractional part, take that fractional part and multiply by the 2. And in that, if we got 1.250, in that only consider the fractional part, that is 0.250 and multiply by 2. You will get 0.0500. Here 0.500 will be multiplied by 2, you will get 1.000. If we can take the 0 also, if we multiply, you will get the 0. So stop it here, and the values of the integer parts of these values. So okay, 101. So write down 0.101 up to down. This is from down to up. Here we have to from up to MSB to LSB. Okay. Take one example here. 24.6. 24.6. This is the decimal number. We have to convert that into binary number. Okay. So here 24 is integer part and 0.6 is your fractional part. So 24 is integer part. So what we have to do here? We have to perform individually. We have to perform for integer part and fractional part. So for 24, the base we are converting into binary. So multiply, divide by 24 by 2. So 2 12 is 24, remainder is 0, and 2 6 is 12, remainder is 0, and 2 3 is 6, remainder is 0, and 2 1 is 2, remainder is 0. Okay. So this we can write from down to up. So that is, this is MSB bit, this is MSB bit, and this is LSB bit. Okay. So the reminders we have to write here 1 0 0 0 0. So 1 0 0 0. 24 is represented by base 10 is represented by 1 0 0 0 base 2. Okay. But we have fractional part also. So that we have to take 0.6. This is fraction part. We have to multiply that with the radix. Here we divided by radix. For fractional part, we have to multiply that by the radix. We are getting 1.2. Okay. In that, only consider the fractional part. 0.2 into 2. That is 0.4. Okay. Take only 0.4. Only fractional part in that result. 0.8. Again, only fractional part is 0.8 into 2. 1.6. Fractional part is 0.6 into 2. That is 1.2. Again, we got the same. So it will repeat. So stop it here. And in these values, take the integer part of these values. Okay. 10011. How to write this 10011 from LSB to MSB or MSB? So in this, consider this as MSB bit. Down is the LSB bit. So here 0.10011. So combine these values. So 24.6 is represented in the binary is 24 is 10000. 0.6 is represented by 10011. So this is the procedure to convert the LSB decimal to binary number system. So decimal to octal number system. So here octal is 8. The base is octal number system is 8. So here we have to divide the integer part by the 8, like binary system procedure only. So and take the quotient and remainder, and again divide that quotient by 8 and take the quotient and remainder. Till this procedure we have to repeat till the quotient we should get is 0, and write the values from up to down. This is MSB bit, this is LSB. The remainders we have to consider here. Okay. So 1 2 3 4. Here we got the remainders 0 2 3 2 2. So 0 MSB will not consider. So write down from here 2 3 2 2. So 2 3 2 2 base 8. Okay. For the same decimal number, here we are taking the fractional part 0.175. We have to convert into octal number. So for that, what we have to do here? we have to multiply that fractional number by 8, and in that result consider only fractional part, only that 0.400, and again multiply by 8, and here you are going to get 3.200. That is the fractional part is 0.200, again multiplied by 8, you will get 1.600. That 0.600 into 8 is 4.800. Only consider this fractional part and multiply by 8, and see here the first one is 400, the last fractional part also 400. So stop here and write down these integer values of these numbers 1, 3, 1, 4, 6. So this is MSB bit and down is LSB bit. So that is 0. MSB bit will be come here. Write down in serial order 1, 3, 1, 4, 6. Okay. For example, if we take 35.45 decimal number, we have to convert that into octal number. How to convert this one? So 35 will be divided by 8 because it is an integer part of the number. So 35 divided by 8 is 8 4 ja 32, remainder is 0. Okay. So we can write this 35 base 10 is equal to 43 base 8. Okay, we have fractional part is 0.45 into 8 is 3.6. 0.6 into 8 is 4.8. 0.8 into 8 is 6.4. 0.4 into 8 is 3.2. 0.2. Here take only fractional parts and multiply by the 8. Into 8 is 1.6. So the fractional part in the first one and last one is same. So stop it here. Okay. So write down the values from up to down. That is for this is MSB bit. This is LSB bit. So 0.45 base 10 is represented by the, so MSB is 0.34631. LSB is least shifting with the rightmost bit is the LSB. So 1, this is base 8. Base 8. So the total 35.45 will be represented by 43 is integer part and decimal part is 34631. Okay. This is the procedure to convert the decimal number to octal number system. So how to convert the decimal to hexadecimal number system? So same procedure like a binary and octal number system. Here the radix r is equal here 16. We are converting the decimal into hexadecimal number system. So divide that number by 16. You will get the value and quotient. And again divide that quotient by 16. You will get 16 4 ja and the remainder will be 13. And 16 0 remainder is 4. Okay, but here you have to represent that. Most of the students will write 4 13 2. It is wrong because the 13 number will be represented in the hexadecimal number by D. 10 is by A, 11 is by B, 12 is by C, 13 is by D. So we have to write down first that one 13 is by D. So write down from down to up 4 D 2 hexadecimal number. Okay, this is the procedure. For fractional part, what we have to do? We have to multiply that fractional part by 16. You will get 2.800. Again, this take only, consider only fractional part and multiply by 16. You are going to get 12.800. So both are same. So stop here. We can write here. To consider only integer part of these two, 2 and 12. So don't write 2 12. Because 12 is represented by, in hexadecimal number, it is represented by C. So 2, the second number is C. Okay. For example, we have to take 22.64. So 22 is integer part. Consider that one. So divided by 13, 16 1 just 16 and the remainder is 6. Okay, 16 0 0, remainder is 1. So we can write that as 16. 22 in the decimal number, that will be represented in the 16 in the hexadecimal number. Okay, the fractional part is 0.64. Here the fractional part is 0.64 into, we have to multiply with the hexadecimal number, the radix is 16. So into 16, that is 10.24. Again multiply by this in 10.24, only consider the fractional part. Okay, that is fractional part of the 10.24 is 0.24 into 16, that is 3.84, and consider 0.84 into 16, we will get the 13.44, and 0.44 into 16, we are going to get is 7.04. Okay, so here in this system only consider these values, integer values, write them from top to down. So here the 10 is represented by A and 3 is represented by 3, 13 is represented by B and 7. Okay, 13 is represented by D and 7. So here we have to write these values from top to down. This is MSB, this is LSB in the fractional part. So A 3, D 7. So combine this integer part and fractional part. So total 22.64 will be represented. Here 22 is represented by 16. Integer part and fractional part is A 3, D 7. So base 16. So simple, just for decimal to convert any number system, for binary or octal or hexadecimal. First we have, for integer part, we have to multiply that number, divide that number by radix number. That is, for a binary the radix is 2, for octal radix is 8, for hexadecimal radix is 16. So we have to, in each state we have to take the quotient and remainder. The quotient again divided by the radix. This procedure will be repeated till up to get the quotient is 0. And consider only remainder values from down to up. That is, the down value will be the whatever this value, that will be the MSB value, and the this value will be the LSB value. Okay, and for integer fractional part, here we have to multiply the fractional value with the radix number. Whatever the result we are getting, in that consider only the fractional value. Again multiply that fractional value with the radix number. Repeat this procedure till to get the fractional value should be repeated. Okay, and write down the value from top to down. The top value will be the MSB bit and down value will be the LS bit, and combine these two integer and fractional part to get the final result. So how to convert the binary to decimal number system? So here, for converting a binary number into its equivalent decimal number, first multiply the bits of binary number with the respective positional weights and then add all those products. So if we have any number A0, A1, A2, A3 dot A minus 1, A minus 2 or A minus 3. Suppose this is any number. Okay. So to convert that binary number into decimal number, so multiply that. So the if it is binary number, the weight will be, for integer part, 2 power 0, 2 power 1, 2 power 2, 2 power 3. For fractional part, 2 power minus 1, 2 power minus 2. Okay. So to find out the binary number, multiply the weight of that value with the positional value. Okay, so A3 into 2 power 3 plus A2 into 2 power 1 2 plus a1 into 2 power 1 plus a0 into 2 power 0 plus a power minus 1 into 2 power minus 1 plus a2 into 2 power minus 2 plus a minus 3 into 2 power minus 3. Okay, like that we have to convert the binary number into decimal number system. Suppose for example we are taking 1 0 1 0 1 1. So each it has only integer part. So the weight, the position, first write down the position 0 1 2 3 4 5. So the weight of the each individual part, so 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. Okay, so 1 into 2 power 0, 1 into 2 power 1, 0 into 2 power 2, 1 into 2 power 3, 0 into 2 power 4 and 1 into 2 power 5. So here find out the weights of individual values and add all these values, we will get the decimal number. Okay, 32 plus 8, 40, 42, 43. Okay, if we add all these weighted values, we will convert that into binary to decimal number system. Okay, so write down the binary number. If it is a fractional value, 10011.11. So the position value. So for the binary point, the left side is integer, right side is fractional part. So here write down process 0, 1, 2, 3. It is after the binary point minus 1, minus 2. And weight of the positional value is 2 power 0, 2 power 1, 2 power 2, 3, 4. It is 2 power minus 1, 2 power minus 2. So the decimal number value it is, so 1 into 2 power 4. So 1 into 2 power 4 plus 0 into 2 power 3 plus 0 into 2 power 2 plus 1 into 2 power 1, 1 into 2 power 0, 1 into 2 power minus 1, 1 into 2 power minus 2. So we have to add all those weighted values, then we will get, that is 16 plus 2 plus 1, 19. It is 0.75 fractional parties. So this is the procedure to convert binary to decimal number system. Binary to octal number system. Here 3 bits of binary is equivalent to 1 octal digit. Okay, so here 2 power 3 is 8. So 3 bits in a binary number is equivalent to 1 octal digit. So start from the binary point and make the groups of 3 bits on both sides of binary point. So if 1 or 2 bits are less while making the group of 3 bits, then include required number of zeros on extreme sides. So if we have less number of grouping in the integer part, add MS beside zeros. Okay, for a fractional part, add zeros to the LS beside. Okay, for example, here we have 1011.10 binary number. We have to convert that into octal number. So here consider only integer part separate and fractional part separate. So divide from binary point to left side 3 3 grouping. Okay, 0 1 1. Here we have only 1. We have to make it as grouping 3. So MSB side add 2 zeros. Okay, the value will not change. It will be 1. If we add 0 0 1 also, it will be 1. So add 2 zeros. Here after the binary point we have only 1 0, but we have to make it to convert into octal, we have to make bits into 3. So add here 0. Okay, so this 0 0 1, write that equivalent value is 1 and 0 1 1 is 3 and 1 0 0 is 4. Okay, so this will be converted into octal number system. So first write down the binary numbers and make it as a 3 3 groups. integer part separately and fractional part separately. If we have any 1 or 2 bits or less while making the group, add zeros at the MSB side and LSB side. Okay, and make grouping and write equivalent values of that octal number. 001 is represented by 1 and 011 represented by 3 and 100 represented by 8. Binary to hexadecimal number. So here 4 bits here in hexadecimal number we will write from 000, that is represented by 0, 001 is represented by 1, like that up to 111 is represented by F. Okay, so to convert this hexadecimal number into binary to hexadecimal numbers, so 2 power 4 is equal 16. Okay, so the 4 bits of binary number is equivalent to 1 hexadecimal digit. So follow these 2 steps for converting the binary into its equivalent hexadecimal number. So start from the binary point and make the groups of 4 bits. Binary point is nothing but this point. Okay, the binary point. So start from the binary point and make the groups of 4 bits on both sides of the binary point. If some bits are less while making the groups of 4 bits, same as binary to octal, here also we have to add zeros on extreme side, either MSB side or LSB side. So here I am taking this 1011 111.1011.010. So this is the binary point. Okay, make group of 4 bits 1011 and 011. So here only we have 1. We have to make it as a 4 digits. So add 3 zeros here at the extreme side and group it as a 4 digit. And for after binary point here for fractional part also make 4 groups 1011, and here we have only 3 bits. So we have to add 0 at the extreme side, that is LSB side. Okay, we have to like that, we have to group the 4 bits we have to make the group of 4 bits. So it is 0001 is represented by here. So 1111 01. So here these 4 ones are 1 and we have only 10 here. So that 2 zeros is added here. So here 0010. Here 0010 is represented in hexadecimal number by 2. So 2. And 111 is represented by F. 1011 in middle we will get 1011, that will be represented by B. Point 1011 by B. 0011 by 3 and 0100 by 4. So this is 4. So this is equivalent to 2FB point B 4 base. We are converting into hexadecimal. So this is equivalent to this number. So just we have to make first to take the binary point and we have to make the group of 4 bits. If we have 1 or 2 bits less at the extreme side, add zeros and make the group of 4 bits and convert the equivalent of hexadecimal number. So this is the procedure to convert the binary to hexadecimal number. Then octal to decimal conversion. So here for converting the octal number into its equivalent decimal number, first multiply the digits of octal number with the respective positional weights and then add all those products. So same. So here this is the 8 power 0, 8 power 1, 8 power 2. So multiply the weight and digit. So 8 power 0 into the digit is 4 and 2 into the weight is 2 power 8, 8 power 1, 7 into 8 power 2. So add all these numbers and you will convert that into decimal number. So octal to binary base conversion. So how we have to convert this octal? We have the octal number. We have to convert into base binary number. So just write down the binary equivalent of the each digit. So for example, I have only integer value here 705. Okay. So to convert that into binary number system, just represent each number by equivalent of binary number. So 5. So octal means here the 5 will be represented by 3 digits. So 101. Okay. That is 2 power 0. This is 2 power 1, 2 power 2. So 1 into 2 power 4 plus 0 plus 1 into 2 power 0 is 1. So that is total 5. Okay, we are getting 5. So 5 is represented by 101. And 0 is represented by 0, 0. 7 is represented by 111. Okay. So just we have to write each digit represented by equivalent of binary number to convert this. So here 145.23. So 5 will be represented by 101. Binary point, this is octal point. So 4 is 100 and 1 is 001. Okay. Here after binary point 2. Here octal point we have 2. So 2 is represented by equivalent 010. Okay, 3 is 011. So this is equivalent of octal to binary base conversion example. Okay, octal to hexadecimal conversion. So here octal to hexadecimal conversion. First what we have to do? Here convert the octal number into its equivalent binary number. First convert the octal number into binary equivalent number. Then binary number into hexadecimal number. So here intermediately we are using binary number system to convert the octal to hexadecimal base conversion. Okay. So for example, if we have 145.23, first what we have to do? We have to convert that into binary equivalent. Octal number into binary equivalent. So here we have to represent the number by 101, 4 is by 100, 1 is by 001. Okay, 2 is by 011, 3 is by 010, 3 is by 011. Okay, and convert the above binary into its equivalent hexagon. So make the 4 groups. Okay, then this 0110 will be represented by 6. This is by 5. 0100 is 4 and 110 is 6. So totally here this will be converted into 16. So first convert this each digit into binary. So each digit in the binary form represent by 3 bits only here. After that make the that into 4 group hexadecimal number and write down the equivalent hexadecimal number. Okay. So hexadecimal to decimal conversion. In hexadecimal to decimal conversions, each digit in the hexadecimal will be multiplied by the weight. So here C, hexadecimal, the weight of this first is 16 power 0, this is 16 power 1, 16 power 2. So A into 16 power 2, B into 16 power 1 plus C into 16 power 0. So C into 16 power 0 plus B into 16 power 1 plus A into 16 power 2. See here in hexadecimal number we will write the number we can represent from 0 to F digit. The letters A to F we will use, but here we have to write the value of those values. A is equal to the 10, B is 11 and C is 12 and multiply those with values with the weighted values and add all those values, you will get the decimal value. Okay. So here A0 3.56 B16 is there. This hexadecimal number we have to convert that into decimal equivalent. So here this hexadecimal point is there. So here first write down the value 16 power 0. Weight of this 0 is 16 power 1, 16 power 2. here after hexadecimal point, this is 60 power minus 1, 16 power minus 2, 16 power minus 3. So here multiply a into 16 power 2 plus position 0 into the weight is 60 power 1 plus b into 16 power 0 plus 5 into 16 power minus 1 plus 6 into 16 power minus 2 plus b into 16 power minus 3. So a value is here 10, b value is here 11. So multiply these values, you will get the values, and add this, you will get values in the hexadecimal number into decimal number. So here hexadecimal to binary conversion. So the process of converting the hexa number into equivalent binary is just opposite to that binary to hexadecimal number. By representing each hexadecimal digit with 4 bits, we will get the equivalent binary number system. So in octal, we represent each digit by 3 bits. In hexadecimal, each hexadecimal number will be represented by into equivalent 4-digit numbers. So here normally for octal 5 will be, we will write 101. For hexadecimal we have to represent 5 in terms of 4 bits, 0 1 0 1. So 0 1 0 1, 6 is 0 1 1 0, 0.4 will be represented by 0 1 1 0, C is represented by this is A, this is B, C. So C is represented by 1100. So this is equivalent of hexadecimal number into binary number system. Here just we have to write each digit is represented by 4-digit equivalent binary number. Hexadecimal to octal conversion. So here for hexadecimal to octal conversion, same as binary to octal to hexa, we use intermediate conversion binary. Here also for hexadecimal to octal, we will use the intermediate conversion, we will use the binary number. So here for hexadecimal to, we have to convert octal. For that procedure, first convert the hexadecimal number into binary number system and binary to octal. So first write down 65.4c, write down the equivalent of hexadecimal into binary number system. So here represent each digit by 4 digits here. So this will be represented by 0110, C is represented by 1100, 5 is represented by 0101, 6 is represented by 0110. So 4 is represented by here 10. So here in each digit we should represented by 4 equivalent binary digit number. 4 is represented by 100. So 0100. C is represented by 1100. 5 is represented by 0101. 6 is represented by 0110. Okay. So just first step we converted the hexadecimal into binary equivalent. Each digit is represented by 4 digits. Then group these numbers into equivalent of 3 groups we have to make. So 101 after binary point, 100 here 01, so you add 0 here at the extreme side. Fractional part also make 3 groups and here add 0. Okay, so here write equivalent of the octal number 1. 100 is 4, 101 is 5, 010 is 2, 011 is 3. 0. This is equivalent of the octal number. Okay. So this is the procedure to convert hexadecimal number into octal number. So here the references are the books followed here is Modern Digital Electrons by R.P. Jain and Digital Design Principles and Practices by Wackel. Here the basic, how to represent the basic number systems will be described here. And the researchgate.net, here we can find how to, why we need the number system conversion. The data will be collected from the researchgate.net. And the problems, some examples are from the session is taken by techtipnow.in. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.